প্রিয় শিক্ষার্থীরা, রাজানগর রানীরহাট ডিগ্রি কলেজ, রাঙ্গুনিয়া, চট্টগ্রামের পক্ষ থেকে অনলাইন ক্লাসে স্বাগতম। আমি পুষ্প বড়ুয়া। আমার প্রিয় শিক্ষার্থীরা, কেমন আছো সবাই? মহামারীর এই বিপদগ্রস্ত দিনগুলোতে আশা রাখছি ভালোই আছো। চলো এবার পড়ালেখা নিয়ে আলাপ করি। আমি আজকের পাঠ্যসূচিতে রেখেছি কিভাবে বিজ্ঞানাগারে টাইট্রেশন করা যায় তার একটি ভিডিও। দেখো, রসায়ন প্রথম পত্রের 2য় ক্লাসে টাইট্রেশন নিয়ে আলোচনা করেছিলাম। তা করতে গিয়ে দ্রবণ প্রস্তুতি নিয়ে আলোচনা করেছিলাম। এবার আসে টাইট্রেশন করার পালা। কিন্তু বিজ্ঞানাগারে যাওয়া এখন আমাদের জন্য অসম্ভব। অথচ নিজ হাতে কাজটা করা উচিত। তাই টাইট্রেশন নিজের হাতে করার সময় কাজটা কিভাবে করতে হবে তা দেখানোর উদ্দেশ্য করে আমি একটা ভিডিও সংযুক্ত করলাম। তোমাদের কাছে ভিডিওটা দেখার অনুরোধ রইল। আগামী ক্লাসে টাইট্রেশনের ডাটার মান বের করা নিয়ে আলোচনা থাকবে। ধন্যবাদ সবাইকে। সুস্থ থেকো, ভালো থেকো।
In this acid-base titration, a standard solution of sodium carbonate will be used to determine the exact concentration of a dilute solution of hydrochloric acid. An indicator solution will be used to help find the end point of the titration. In this case, methyl orange will be used, which will turn from a red to yellow. Here is the equation for our reaction. Pour approximately 50 centimetre cubed of your stock sodium carbonate solution into a dry, clean beaker. Rinse the burette several times with distilled water. Using the funnel, add a little of the sodium carbonate solution to rinse through the burette above and below the tap. Discard the rinsings and repeat the step 2 more times. This makes sure that you do not dilute the solution when you fill the burette. Fill the burette with sodium carbonate solution above the 0 mark and remove the funnel. Using the tap at the base of the burette, allow the sodium carbonate solution to flow into the beaker until the level of liquid is at or a little below the 0 mark. Ensure there are no air bubbles in the nozzle. These can be removed by just running a little more solution through the tap. Next, you'll need to record the level of the solution in the burette. It can be tricky to see the meniscus clearly. It helps to hold a piece of white card behind the burette so that it lights up the bottom of the meniscus. Take the first burette reading with the meniscus at eye level. Take a reading from the bottom of the meniscus to the nearest 0.05 centimetre cubed. Make a note of the reading. Rinse the pipette with some distilled water, and then 2 or 3 times with some of the dilute hydrochloric acid solution. Rinse the conical flask with distilled water only. Using the pipette and the pipette filler, transfer exactly 25 centimetre cubed of the hydrochloric acid solution into the clean conical flask. Allow the pipette to drain for several seconds after it has been emptied. Then touch the tip against the side of the flask. Do not force the last drop of liquid from the tip of the pipette. Add 2 to 3 drops of methyl orange indicator to the flask. Take note of the colour of the solution, placing a white tile underneath the conical flask to make the colour more obvious. Before proceeding with the main experiment, carry out a rough titration. This is to determine roughly how much of the alkaline solution is needed to neutralise the acid and will give us an approximate value of the endpoint. Start by running the sodium carbonate solution quickly from the burette into the conical flask while swirling the contents. When the colour change of the indicator starts to be more persistent, slow down the flow. Then start by adding 0.5 centimetre cubed at a time until the end point is reached. Swirl the flask continuously until this is achieved. Note the burette reading. Then, take your conical flask, empty and wash it, and using your pipette, add a second 25 centimetre cubed sample of hydrochloric acid solution, along with those 2 to 3 drops of methyl orange indicator. Now, you're ready for your first accurate titration. As the amount of sodium carbonate required to reach the endpoint is now roughly known, you can start by rapidly adding the solution until the amount added is approximately 2 centimetre cubed from the endpoint. As the endpoint is approached, gently swirl the conical flask. Then, while continuing to swirl, add the sodium carbonate solution drop by drop from the burette. After the addition of each drop, rinse the tip of the burette with distilled water. Swirl the flask, then rinse the side of the conical flask with further distilled water. When a permanent colour change occurs, note the reading. Repeat the titration until 2 titers agree within 0.1 centimetre cubed. Once you've recorded your data, you should have all you need to calculate the concentration of the hydrochloric acid.